This is still the 2021 exam. The closest is 11:20. The question says, this is question 1, A, part 3 now. Okay, so let A be a set from -2 to 2, B a set from 0 to 8, and C be a set from -5 to 11. What's the inverse of set? B subsets of the inverse of set R. So the inverse of set is R, set of real numbers. What should we find? Find the set, find A intersection B minus C, and express your answer in the interval notation. Or you can even add that, let the answer be on the number line and see what happens. So this is a question that troubles people the most. Sets. So we are given intervals as our sets, and we are told the answer must be in interval notation. Very easy. So first we find A intersection B. So we have A intersection B. I'll do it in 2 ways. The first way is a direct one. No need for the number line. Intersection B. How do you get this? Well, because of intersection, we look at the left boundaries of the 2 sets, -2 and 0, and pick the one that is bigger than the other. So between these 2, pick the bigger number. So we'll pick 0. It's bigger than -2. And then you go on the right boundaries. Between 2 and 8, you pick the smaller number. So between 2 and 8, 2 is smaller than 8, so we pick 2. When the number you pick it with its type of bracket. So 2 has this type. So pick the same that 2 has. That is A intersection B. So why are we saying pick that, pick that? If we went on the number line, we are going to have -2 all the way up to +2. And this would have been an interval open, open. And then we are going to have 0 up to 8, closed, open, like that. The intersection would be where the 2 lines are meeting. Where are the 2 lines meeting? They are meeting from 0 to 2. You consider the closed and open if the number you're picking is closed, then you pick the closed. If the number you're picking is open, then you pick the open.
So that's for both numbers. The first number that you pick, the smaller number, or maybe it's just for the last number, the bigger number.
What's the question again?
You said we consider the brackets. So now I'm asking that, do we consider for both the bigger number and the smaller number when picking the numbers for the brackets?
Yes.
All right, thank you.
Okay. Okay, so I've explained why I said pick the bigger, pick the smaller. If you forget, use the number line. What
Sorry,
next? Hello?
can you kindly repeat on the shading part on the number line?
You shade where the two lines are meeting if you're looking for intersection. If you shaded here, you'd have been shading only one line. There's no intersection there. Intersection, you want the common piece. The piece being shared by two intervals. That's the region you shade. Your shadings are touching two lines. That's why you have to shade from 0 to 2. Remember, it's open at 0. It's open at 2. So you pick the, if you have open and closed and its intersection, you pick the open. Okay? Note, if its intersection, okay? The two numbers, if it's intersection and you have one closed and one open. Pick open. Okay? But if it's union and you have one closed and one open, pick closed. Obviously, we'll have more examples. We'll have one where there'll be union later as we move. So let's move. So this is A intersection B. Okay, we must subtract the C elements. Okay, we are subtracting. So I now get A intersection B minus C. So I have my A intersection B, 0 to 2. Minus, what is C? C is negative 5 to 11. 11 is even closed. To subtract, I have my set 0 up to 2. Then I remove all the elements that are in C. As I remove, you find that in C, 0,2 is a subset of this. So my answer is empty. I will remain with nothing. Because I will take the whole interval from 0 to 2. It will be gone. I haven't gotten it. If you take,
Try to
you put on the number line is here. And you have 0 to 2. 0 to 2. Open. Open. You also have negative 5 to 11. Closed. Open. Remove that. Remove the bigger line from the smaller one. So you remove everything in there. Okay? Or, well, if you don't understand it this way, you write it. It will become A intersection B intersection C complement. Where is C complement? You start from here to go this side. Start from there, go the other side. Then intersect now this C complement to this A intersection B. They don't intersect anywhere. So the answer becomes empty. You get? So how do you get the intersection? The intersection, we've shaded. I don't know, not big deal. You shade, or you pick the bigger number from the left, the smaller from the right. Or forget about that, you shade. You have 0 to 2. Then now, after you have 0 to 2 as your A intersection B, your question is asking for A intersection B minus C. Minus is subtraction. Subtract all the elements that are in C, remove them from A intersection B. If this box is A intersection B, okay, and this box here is C, and in C I have 1, 2, 3. In A intersection B, I have 2, 4, 5. Remove C from A intersection B. I will start checking. Do I have 1 in A intersection B? No. Okay, that's okay. Do I have 2 in A intersection B? Yes. I'll come and remove it from here. Do I have 3? No. Okay, I'm done with A intersection B. The question is, what have we remained with in A intersection B? We've remained with 5 and 4. We've subtracted C from A intersection B. But if you don't get it as subtraction, then get it as intersection C complement. C complement is here when we sketch, when you put on the number line. This is C complement. Then you can shade A intersection B. It's here. Do we have anywhere where our shadings are meeting? No. Because they're not meeting, the answer is empty. Okay. Next. Interval notation. This is interval notation. It is empty. Oh, they insist interval. Empty. Nothing. Done. For union, it's a different one. When we have union, I'll demonstrate. Don't worry. For now, enjoy the intersection. Pick bigger, pick small. We are packing the information in that order. Today, you've packed intersection. The other day, you pack union. Then you have two pieces packed separately, but very same. If I present union here, you start saying, when do you pick bigger, smaller? I've confused. Is it when it's union or? So today, pick bigger, pick smaller. We are dealing with intersection. Next question. we move to B. Let F be the quadratic. What do you do? 1, sketch it, indicating all intercepts and turning points. 2, what do you do? Is F even, odd, or neither? Well, we'll answer that question. Whatever you say, justify. The third one, solve F greater than 0. So is that sketch? Yeah, right. So sketch F of x is equal to x squared minus 4x minus 5. This question does not say complete the square. It has just said sketch. I can use any method I know that can help me sketch. But the easiest one to sketch, for every sketch, just go for the intercept first. So find the intercept. Y-intercept. Y-intercept, you go in F, wherever there is x, put 0. And you get -5. So it's a point 0, -5. That is Y-intercept. X-intercept. That's why now we equate F to 0. We want to solve x squared minus 4x minus 5 is equal to 0. You can use any method. I'm able to see the factors here. So I'll use product factor method. The product is -5. The sum is -4. The factors, -5 and +1. So I'll have an easy time. This implies that I have x squared plus x minus 5x minus 5 is 0. Implying that when you factor out x, we get this. So we have x is equal to -1 and x is equal to +5. These are the x-intercepts. Of course, it's always -1, 0, 5, 0. Because they're sitting on the x-axis where y is 0. What next? The most important point, the turning point. For a quadratic, there are two ways. The easiest, if you want, you can use the line of symmetry. So you say, well, what is x? It's -d over 2a. Okay, what is b? B is -4. What is a? A is 1. So I have +4 over 2, which is +2. This value x, you substitute it in f. F of 2. You get 2 squared minus 4 times 2 minus 5. This is 4 minus 8 minus 5. 4 minus 8, that is -4. Minus 5, that's -9. So the point is 2, -9. What point is it? If a, which is 1, is greater than 0, minimum. Minimum turning point. So we have the sketch now. We have everything that we needed. 1, turning point at 2, -9. So it's down here. y-intercept -5, x-intercept -1 and 5. So we have the graph. So this is 5, and this is -1, and this is -5. And done with the sketch. 5 marks. Yeah, if you like calculus so much, you differentiate to say, okay, what is f prime? We're looking for a turning point. It's 2x minus 4, equated to 0. You get x is equal to 2. Substitute to get -9. You want to know whether it is minimum or maximum? Differentiate again. You get +2, greater than 0. So it's minimum.
Sir,
Hello.
sir, this method that we use to find the turning point, yeah, does it apply everywhere when you're doing it? So this equation,
When you're given,
like, can you apply it at any time when you're finding turning point for a quadratic?
for every quadratic, yes, it applies anywhere. And remember, a quadratic is x to the power 2, is it? If you see x power 3 and you want to call it quadratic, that's not true. It's only x to the power 2 that we call quadratic. So it applies for all such functions.
Thank you, sir.
Okay.
Sir, kindly repeat on the minimum statement.
If a quadratic always comes in the form ax squared plus bx plus c. Should a be positive, the point you get will be called the minimum turning point. Should a be negative, the point you get will be called the maximum. Is that okay? I'm not going to allow you to go in the exam without knowing how to sketch a quadratic function. When I give you an exam on Saturday, there are questions, because it will be online, we don't have enough venues, and also the timings. I understand you must be very busy. But this will be part of your exercise. So when I give you on Saturday, I'll give you in the evenings. So just try and see how far you can go. It's a 3 hours assessment, because the exam is for 3 hours. So you run through to see and solve. That does not mean you have to solve mathematics the whole day. That means on your timetable, you adjust a bit so that on Saturday, you are studying math from 19 to 22. That's normal. That's how we study. At least 3 hours a course. So that 3 hours for math, you're using it to assess yourself if you've done enough between now and Friday. You also do quite a lot. You may touch every concept. And then you assess yourself. Was the week okay? How far did I go? And then I'll pick some questions that I want to see. One of them will be the quadratic. Because I tell you in test 1, I told you the quadratic will be there for you to sketch. And you ignored. Went there, you found it. Came out, you didn't want to greet me. I'll tell you again in the exam.
Sorry, sir. So this way of finding the turning point, this method you have used, it applies everywhere when finding the turning point.
This method of x is equal to b over 2a.
Yes, sir.
For every quadratic, it applies.
Okay, okay, sir.
Okay. Is the function even? Let's check. Don't worry for another without factors. Obviously, you'll see. When there are no factors and you want to get the zeros, use a formula. Direct. And you know the formula. X is equal to negative b plus or minus b squared minus 4ac over 2a. If there are no factors. Okay. Is the function even? The function will be even if f of negative x turns out to be f of x itself. So let's check. We put negative x in the function. So the function is x squared. So we have negative x squared minus 4 minus x minus 5. This comes out to be x squared plus 4x minus 5. Remember, f of x is x squared minus 4x minus 5. So this is not the same thing as f of x. Not even. Okay? A function is an odd function. It's an odd function if f of negative x, it gives us negative f of x. Okay? So you go back where we ended, pick this guy and check if it's odd. Factor out the negative. What do we get inside? We have negative x squared minus 4x plus 5. Purely not negative f of x. So what does it mean? This f is neither even nor odd. Or you say, I may have issues here. Then you know f of x is x squared minus 4x minus 5. Find also f of negative x. It's x squared plus 4x minus 5. Find also negative f of x. It's negative x squared plus 4x plus 5. As you can see, there's nothing that is equal here. So because they are all not equal, the function is neither. Function is neither. So this was the second part. The third part, solve for f of x greater than 0. We come back to the sketch. Where is the function above the x-axis? The curve is above the x-axis. Here and here. The curve is above the x-axis. For which values of x? From negative infinity all the way up to negative 1. Union from 5 all the way up to positive infinity. As you can see, from 5 going this side, the function will be above the x-axis. That is being greater than 0. From negative infinity all the way up to negative 1, the function will be below. The function will be above the x-axis. When you say the function, you mean the curve. The curve. It's about the curve. That's how you solve this setup.
Sorry, can you repeat what you said?
When you say f greater than 0, we mean the values of the curve that are above the x-axis. So you are picking, because f is the curve, it's the y. So where is y bigger than 0? Y is bigger than 0, where the lines are above the x-axis. So you pick those intervals. In the exam, you write with whatever you have. If it's a pen, use a pen. And in fact, for the exam, a pen is better. Because me, I don't like it in the tests or in the exam. You're invigilating and you are sitting at the corner and you put up your hand. The invigilator walks about a minute to where you are. And then you're also waiting, not doing anything. They come there, what do you want? I'm asking for a pencil. From who? Anyone. And they're not doing anything, waiting for a pencil. They look for a pencil for you, find you a pencil. They give you, then that's when you start writing. You have lost about 2 to 3 minutes of not doing anything, just waiting for a pencil. And you sketch what you don't know. If you know it, even using a pen, it will come out.
So I didn't finish explaining.
On which part? Explain the last part.
That's what Tim said.
So I know you guys are used to doing the imperative thing using the table, but not for this question. This question is saying, solve for f of x greater than 0. Greater than 0 means pick the interval on the x values where the curve is above the x-axis. That's what the question is asking. So what do we pick? We pick from negative infinite all the way up to -1. The curve is above the x-axis in this section. We don't have a curve down here, so we can't call it f greater than 0. Also on the right, after 5 on the x values, the function is above the x-axis. So that's why we're picking those pieces there. You're looking at what is happening to the y values. For which y values? I mean, for which x values is the y bigger than x-axis?
What if we were asked to find the less values?
You pick where the function is below the x-axis. If they say less, you pick this region. Like that.
I don't even think they can.
If they said less, you pick the less part. It's not 2 up, it's not -2 up to 9. It's 2, -9. This is a point. You find the x value of the turning point by using -b/2a. These are quadratics, and we know -b/2a is the line of symmetry. So we can use the line of symmetry coordinate to find the corresponding y value at that turning point. Yeah, I would have used the cross brackets. So Zoom will be signing out very soon.
So repeat on the even and odd.
On the even and odd, you just use the definitions. You want to check if when you take when you take a negative x inside, you get a negative f, or you get the original f. But we've got none of them. So I'm saying it's neither even or odd. You check if any of these will be equal.